Okay. Um, okay. So that's how basically you export, as long as the first character of your variable, of your function, of your any data types that you have within your um, package, then those are going to be able to be used in your executable files, okay, or the executable package. So variables not starting with an uppercase letter are private. Okay. So now in other languages, to do something like this, those languages, they have created a unnecessary keywords like a public and private. Okay. Now when I start, Go language, I think there is no need for having a private and public keyword in C++. They could have gone with the same kind of a concept. So all you have to do is to remember either to use the uppercase first character or
I have a
have
question actually.
yeah. Go ahead.
Suppose you put here package name is rectangle, and you put two functions area and diagonal. What
Uh-huh.
happened? You already have some other package also have the same function.
So you always will be able to access these functions with the package name.
Oh, okay,
This,
okay. This is
okay.
act like a namespace for rectangle.
Right, yeah. So and you will see it pretty soon in a minute.
Oh,
Okay.
okay, sure.
Okay. So that's why it cannot collide with
Okay, okay.
so with other packages.
Okay, thank you.
Uh, so variables not sharing with an uppercase letter are private. Okay. So
Mhm.
that means they don't in Go language they don't call a private, they call it unexported. Okay. Either they are exported or unexported. That's how they use the term. So source files belonging to a package should be placed in their own folder. So if you like I was earlier, going over, um, if you created a package, okay, first of all, you should create a directory name or the folder name same as the package name. Now, when you are creating a package and that package has multiple source files, okay, multiple source file with a .go in there, you can always have that, no problem. All must be in the same directory, and every source file first line must start with the keyword package, and then after that the name of the package. Okay.
Okay.
So it is a convention in Go language to name the folder with the same name as the package name. Okay, that's what we just went over. All files inside the package folder should start with the this line. That's what we just discussed. Okay. All right. So this is a simple package. In this package, first line is starting with the package name, rectangle. Okay. And then you can treat this package just like a normal source file. And I'm importing a math in there. Okay. So math is another package. So you can import a standard package within your own custom package, or you can even import, if you have a third party, some package that you want to use, or your own package that you wrote for something and you want to use it in your own package. So you can do that too. You can import it in here. Okay, so I'm using a math package. The reason I'm using a math package is because of this line number 10. Okay, math dot square. So as you can see, the square is a function which is inside this standard math package. Okay, but even for the standard packages, the first character of the function is a capital letter. Okay, and that means is a exported a name. So, and then to access this function, you use a package name with a dot operator, okay? And that's how you access anything from within the package, or from the package, not within, but from the package, okay? That's what it is happening in here. So, um, I'll give you the demo in a minute. The function names area and diagonal starts with the uppercase. You see that, the function, they start with the uppercase because they are exported. Only exported functions and variables can be accessed from other packages. Okay, so otherwise you can't use them. All right, so now let's look at it how it is used in the main package. So in the main package, now I made a little mistake. Instead of importing this package called rectangle, okay, right here there's a small mistake on line number 4. It's called geometry. Okay, it is not really geometry. It is um, basically it is a package. Um, it's a rectangle. Okay, and I'll go over in a minute. So this should be a rectangle. Now, within the main function, I am creating these variables at line number 8. Okay, rectangle length, rectangle width, and they both are float type. And while I'm creating, I'm initializing both variables, and then doing the print line at line number 9, and then at line number 12, I am so this is line number 12 and 13, basically a continuation of this line. So at line number 13, as you can see, I'm using a rectangle package. I don't know why I screwed up right here, but anyway, so this rectangle package is used uh, because this area is in the function which has been exported from the rectangle package. Okay. Similarly, this diagonal function is exported. So that's why I'm using a rectangle package name. Okay. So if I go and show it to you here, which is vi and then 6 1. Okay, so this is the function right here. So what I did, I wanted to show you some other thing too. So basically, in this example, the bug is, or the error is right here. Okay, this package name should not be there. So what I did is I put a underscore. Whenever you put an underscore, that means that you have the package, but you have not um, um, wrote any code utilizing that package, okay? Or you haven't instrumented the code from that package. So what you can do is to put an underscore in front of the name of the package. So then the compiler knows that package, you will be writing it later on. Okay, so it would not generate any error. Now, this rectangle package that I have, which is a directory, and I will show it to you, and this main code that I just went over is there, which is utilizing the this rectangle package right here. Okay, with the area function, and rectangle package with the diagonal function. Okay, so if I go to the rectangle package, which is a directory, and bring up that example. This is the example that you have it in your class notes. Okay, right here. This is the same thing. Okay, so this, as you can see, the package name is rectangle. Okay, and basically um, rectangle is the name of the package, and that's all really is important. And then within this package we are using a standard library math package, so I'm using it right here with a square root function. Okay, that is called.
So
So
this
now,
this file actually the same within the same directory as the file which call this package rectangle
no,
package.
it's in the different directory. You see,
Oh,
it is under, it's
one
on
level.
the,
Yeah. Okay. Okay.
yeah,
That's why you put dot slash rectangle. That is the
right,
subdirectory
exactly,
name.
yeah, exactly,
Oh,
exactly.
subdirectory name. Okay.
Yeah, so that's why we use a dot and then the package name. Okay. Now, as I was explaining it to you about this guy right here, so you know where the package is, and I was explaining it to you just now about this guy right here, the main, and I told you just now that if you don't want to use any package, okay,
Mm-hmm.
because you haven't instrumented the code from that package, you can always put a underscore in front of the name of the package. Okay, but but if you don't have this directory and nothing inside that directory, then you will get an error. You understand what I'm saying?
Mm-hmm.
Even if you put this underscore in there, okay, and that means that you are not instrumenting the code within your current source code right now. You will do it later. You just haven't worked out the logic yet. Okay, so but 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 if you don't have the this directory,
Mm-hmm.
geometry directory, okay, it won't it won't it will give you the error. You have to have this directory created, even though you do it like this. Even though you do it like this, okay.
Okay.
So now, if I run it, this program right here, I just say go run, okay. It knows where the package is located, okay, and it has both packages. Geometry is there too, but geometry is basically empty. I don't really have in there, so it will be able to run. Okay, if I change, so just to give you the example, I will just say um, uh, uh, and now if I run it, I should get an error. You see, see, even though in my main code I have a underscore in front of that name. Okay, so that's what it happens. You will get an error. So now let me rename this again. Move 918. And if I do it now, everything should be okay. Okay.
Okay.
All right. So we went over this. So that is done. Uh, example. And I already explained it to you this. It is illegal in Go to import a package and not to use it anywhere within the code. So that's why you use a underscore, okay, in front of the package name, and that's what I was showing it to you just now. Um, so keep track of silencers and make sure to remove them at the end of the development. So, you either instrument the code for these silencers meaning the package that you have it in your code, but you have not written a single line and you are about to finish your project, then you better remove them, you know, otherwise they will get, people will get confused. Plus, as I was showing it to you, that you have to have a directory created with it for this. Otherwise, it won't really work. Okay. All right.
What was the underline for again?
Excuse me.
The underline. What was that for again?
This underscore is for the
Yeah.
package that you want to use it in future, that you do not have any code written for it. But
Oh, right. Okay. Yeah, I understand now. I'm sorry. I missed something there. I know what it is now. Okay.
Yeah, that's
Thank
fine.
you.
No problem. Yeah. Okay. Nested packages. So basically, nest a package inside another package. Okay, just like the way that we just saw that the package that a rectangle that I have, and within that package, I am using a standard package. So basically, I'm nesting the package. But you can do the nested packages for your own custom packages as well. Okay, so package is just a directory. It's like creating a subdirectory inside an already existing package. Okay, so so it is similar to the concept as having that you have some package at a parent level, and then the child would be another package, which is like a subdirectory. Okay, so that's how you nest the packages. To provide a relative path of the nested package. So the whole thing boils down to the path. Okay, if you don't have the path properly done, then it won't be able to find the package and you will get an error message. Okay. So we've been using a go run command, which compiles and executes your program, right, so far. But you can use the go install command, okay, which compiles the package and creates a binary executable files or a package archive. So this one, if you have a package, then it will also create a .a file. Whatever the package name is, with the name of the package and .a file will be created. So let's see if we can create the .a file in here. So far we were using this guy, right? So instead of a go run, we just say go install. Okay, and let's see what it does. Um, it might have installed it in my, where it is installed. It may have
And the rectangle subdirectory?
No, I don't think. Let me check, but I don't think. No, it
Oh,
installed it in the under. Remember, if I do the echo on go path, you know, and under this directory, if I just do the ls and then $sign go path, see, oops, sorry. So it is under, so I should have under the bin directory. So I just should say ls underscore or bin right there. So this is this is the binary file name, right? That's the program name, and then I have a package. So basically, instead of a bin, I just say package. So where did it put the? I'm just wondering where the heck it put it.
You have to go to the Go bin, I think.
No, Go bin will have the here. This is a Go bin.
Oh, this is Go bin. Okay.
Yeah, all these are Go bin, but it doesn't have. This is a binary file.
Mm-hmm.
Go bin is a binary file. Okay, but I'm looking for a .a file. Okay, but
I've never seen one.
Huh? No, .a
I've
file
never
will
seen
be. But Billy, the .a file will be created only if you use the install.
Okay.
I use install all the time.
Okay, let's
That's
do
all
it this way.
I never use the run.
Okay, let's do it this way. I will do it a little differently. Build. And now what it's going to do, instead of install, I'm using a build, then it is going to create a binary file in the same directory. Okay. Go build should create a binary file in the same directory. Right here. You see that? But what about the package? Now, let me see. Yeah, I don't know where it's putting the .a file. It should create
Well,
a.
I have a whole bunch of things compiled on my system here, and I just did a global search through the entire directory hierarchy for .a files. It found some, but they're part of the files are distributed with the operating system when you install it. That's it. And there's only a few of them.
Okay, let me do some investigation, but I know that you can create a .a file with this, with golang. Okay, I think it's a some switch that you have to pass while you're building it. So there is a switch that is missing. So we'll figure it out. Let's come back to it. Okay.
Okay.
If I remember tonight, I will let you know. Otherwise, next week I'll let you know. Okay. So after installing third-party packages, Go language compiles the package and creates a package archive. Okay, so basically that's how. So package archives are, so when I was showing it to you, this Go ls Go slash, and then if I do the it's not finding anyway. I'll just have to come back to the .a, how to create it. All right, so let's move on. Package scope. A package scope is a region within a package where a declared variable is accessible from within a package across all files in the package. Okay, so now how do you create a package scope? Okay, so remember, packages might have a multiple files. Okay, and they will always be in the same directory as the package name. Now, if you create a global variable in one of those files, okay, that global variable will be, even if it is all small characters, it will be only be accessible from within those files. Guys got it? Okay. So I'm going to repeat
So just within the files in the package.
Correct. Yeah. As long, even if it is a small character, the first character of that variable is small, it is still will be able to access within any of those files within that package.
Okay.
Of course, if it's a small, then it would not be able to access outside the package. Okay? So that's what this is saying. So this region is the topmost block of any file in the package. So that's a topmost. You know, if you have a global variable, then it is accessible from any files within the package. And of course, if it is a capital letter within the package, and it is global in any of the file, then it is accessible from everywhere, from outside the package as well as within the package. Okay, now that's where you can run into a big issue of colliding the names. Okay, so your namespace is basically gets corrupted, you know, because if let's say you bought a third-party package. Okay, people buy the packages, right? So you bought a third-party package, and those guys were very new with the Go language, and they created a variable with a capital letter, and it is a global variable in one of the files that they have in their package. Now, you imported that package in your code, and you happen to use the same name as they have used it. Okay, then then you are going to get an error message, okay, because it's going to collide. It's in the global space. Okay, so that's why the globals are really not good idea to use in any of the languages. Really, you always should avoid using a global, or you pass the parameters, you know, to your functions. Okay, let's go over structs and exported and unexported members. Okay. So we kind of already covered what the exported and unexported variables are. We are going to now look into the field names of the struct as exported and unexported. Okay, so now we are talking about within the type, what the effects that the exported and unexported fields will have. So defining exported and unexported members for structs work the exact same way as identifiers, you know. So any variables that you would have within your code, it works the same way. Okay? The only idea is that those are within the struct body. So they are the fields of the struct. If a field or a method name starts with a capital letter, the member is exported and is accessible outside of the package. Okay, so as long as it is first character is a capital letter, then it's exported. If a field or method starts with a lowercase letter, the member is unexported and does not have accessibility outside of the package. Okay. So in this case, what we are looking at this code, first of all, this is a package called animals, the same package that we went over. And in that package, I have a struct, okay, called dog. So new data type is been getting created, but within that data type, I have three fields, okay, a name, bark strength, and an age. So as you can see, age is a small character, okay, and that means it's a unexported field. So you can't really see that field in there. So if you do come here and use it um, in your main program, that package, you know, this package ends right at line number 8. So in your main program, you have to import the package name, and basically once you import it, then you can use any functions or anything that you want from that package. So I'm using this struct, and then from within that struct, I'm trying to use the field which is not exported. and I will get an error at this time, unknown, as you can see, this is the error message, okay, because this is not exported. Okay, so any questions?
No, I think I got that.
Okay. I'm just trying to find out that I'm just surprised Craig have never sent any messages or nothing. Okay. Uh, let's move on to the next example. So embedding struct or the nested struct. So we covered the embedding the struct not last week, about 2 weeks ago. Okay, so that's what this is all about. So in this case also you export the field, okay, and as long as you have the first character of the field uppercase, that field will be exported. Now, if you are using this nested structure right here, so I'm using inside the dog, or I'm using animal. So dog is an animal. Okay. So basically, our dog, a dog is an animal. So that gives us like a hierarchy kind of a thing. Dog is an animal, so it's in there, and this this letter, for the um, uh, for anonymous struct field must be capital letter. Otherwise, you would not be able to access anything from this animal struct. Okay. So this is how it goes right here. So this is a package, and now we want to use it in our main program. So import the package name animals, and then create um, instance of a dog struct. So at line number 9, we are creating an instance of a dog struct, and once you do that, within this um, instance, as you can see, since we have a anonymous a struct field within the dog, we can use the anonymous struct name right at line number 9, right at line number 11, and it would not be any issue as long as this anonymous struct has a capital letter, the first letter of that anonymous struct name. Okay, so the output, once we run the program, we get this output right here. Okay.
Mm-hmm.
All right, so change the animal type from exported to unexported by changing the first letter of the type's name to a lowercase. So now what we are doing, instead of having at line number 11 in this example, um, 4, we are changing it to lowercase. Okay, that means we are making it unexported. Now, when we use it in this, in the main, when we import that package and trying to use it, this anonymous field, then I will have an error condition. This would not be able to see that anonymous struct. Okay, so the main program that can't compile because trying to access the unexported type animal from inside the composite lookup. Okay, so it would not work, and it will generate this error message right here. Okay, fix the compiler error by initializing the exported field from unexported embedded type outside of the composite. So the way that you can do that is by um, by uh, so in here what we did is um, created the instance uh, of the dog uh, by initializing the package name, animals, and then dot the struct within that package. So in here we are able to use the where is the animal? Let me see. Animal dot animals. Okay. Uh, oh, okay. So what we did here is, as you can see, this in the animal struct, I have a name and age, right? Now, the way that I'm accessing name and age in this example is by um, going using the instance of a dog. Okay. Once I create a dog instance, then when I'm using the dog instance, then I'm not really worried about the anonymous um, this struct within the package. Okay, right here, this anonymous struct. I don't care about it because once I create a dog instance, in the example that we are talking about, I can access any of the fields from the animal, okay, as long as they are done outside of initial creation um, of the instance. So this is outside. So this is at line number 9 to 11. That's the creation of the instance, and then outside that, after the instance is created, which is a dog name, the instance name is a dog, then I can just use the field names from the anonymous structure. Okay, so that's not an error condition. That is perfectly fine, even though anonymous structure is small characters, if you can see right here. Okay, even though it is small character, but I'm not using this anonymous structure to access these fields. I'm just first creating the dog instance, and then since this struct is already composed within this dog, and I can directly use a dot operator to access the animal fields. Okay. All right. So the exported fields that were embedded into the dog type from the animal type um, are accessible even though they came from unexported. Okay, so that is the reason that this works, because we have the instance first created and then using that instance to access the anonymous struct fields. Okay, so the exported fields keep their exported status when the type is embedded. So basically, that's how the language works. So exported fields keep their exported status when the type is embedded. So if the type is embedded, then the it always be exported. If it is exported from within the anonymous structure name with the capital letter, then that means it's exported. Okay, so it will keep it as its field will always be exported. Okay. All right. So let's. Do you guys have any questions here?
Not at this point, no.
Okay. All right. So now let's go over init function. Now, the init function is incredibly powerful and easier to use within Go language. So as you know, with the name init means initialization. Okay, so init functions are used for that purpose. Okay, and whatever you put it in inside the init function, that will happen first. Okay, so the init function can be used within a package or within a executable, and it will be called only one time. So you cannot make a call yourself. If once you have the body of init function in your code, doesn't matter if it is in the package or in your regular source file, okay, or the main package, it will be only called one time. So it does not take any arguments and does not return any value. Okay, so basically, it does not have uh, you cannot pass the arguments to it, and no return type can be returned from it. So um, the Go language program does not explicitly call init function. So you cannot call the init function itself from the body of your code from any place. Typically, init function is used for tasks that need to be done only one time. You know? So you can think in about init function similar to constructors, right? You know, in C++, similar to that. Not exactly like that, but yeah, similar to that. So basically, whenever you want to do some tasks that need to be done only once, then the tasks such as database connections, loading in configuration from locally stored configuration file, register with various services, registries, perform any number of other tasks. So any of these tasks that you need to be done one time only, then you should put them into the init function. Okay. So one of the important tasks init function achieve is to initialize global variables that cannot be initialized in the global context. Okay. So basically, that means the initialization of the global variable can occur only one time if you have init function within the init function. Okay. So in this case, I have in this example 6-5. I have a code right here that starts with line number 4 with a array of 10 integers, right? This will create an array of 10 integers. The array name is a ticket num, and within that I have a init function. So you declare the body of init function, okay? And then within the body of this init function, you can do whatever you want to. But in this case, particular case, this is actually going to print out this message, call to initialize the ticket number, and then it has a for loop, okay? And so it will initialize the ticket number within this for loop 10 times. Now in the main, so this is done first, and then in the main, by the time you come to the main and do the print on the ticket number, all the numbers will be initialized. Okay, pretty straightforward, right? Okay, so now let's look at more more different ways that you can use the init function. It is allowed to have init function in custom packages. So you can have init function in the custom package, like animal package that we were talking earlier. Okay, I can put that init function in that package as well. So each package will perform setting up various related tasks. So, as many packages that you write, those packages might have the init function. In fact, as many files that you have within that package, you can have init function in every file. So each package will perform setting up various related tasks. When custom package is imported into an application, first init function is called from the package. Okay, so when you import it, the very first, if there is an init function in your package, then that init function will be called first before even it starts your own application code. So in here, I have a package called broker. So in this broker package, I have a function or init function, and in this init function, all I'm just doing is calling this print line. Okay, that's all. And then I have another package called database. Okay, that's a separate package, and in there is the init function as well. Okay, so there are two, both packages have an init function, and of course, I'm not showing other code in here, but there could be many other code or the functions in these both packages. Now, in the main, all I'm doing is importing the database and the broker package. Okay, so both will be imported, and depending upon which one is imported first, the init function will be called from that package. Okay, so it depends upon which was imported first. And then in the main, all once these packages are imported, I can use this package name and then access these variables, because this is a capital letter right here. So I create a variable name, okay, in each package, the same variable name. Okay, so they are not going to collide, because when we are accessing it, we are accessing it with the package and then the variable name itself. Okay, as long as they are exported, there is no issues. Okay, so now just to make sure that it all works, so I have a broker, you know, um, in here, and then in the broker exact same code that I have. Only thing that I did is modify a little bit here to when it prints, so we can easily identify which one is called first. Okay, so I modified this code, and then if I go back to the database, and in here the database package, package name database, and then again, I'm saying that okay, this is called the init function is in the database. Okay, now when I use it in the code, which is, I'm just going to say go run, and then what is it, ex6 dash 06. Okay. So notice that the way that it is running, so it is printing this database from the database package. So init function was called, okay, and then this was called from the broker init function, okay, and then these two database package, these are coming from right here from the main. So that really doesn't make any difference in which order that you write. Whatever the order that you wrote, that's the order that it will show up right here. But this order makes a difference, order right here. So what I'm going to do is to open up this file, okay, and change the order right here. So I'll make this database go down here, okay, and then the order, since the order is changed, it should make a difference. Do you see? Before the database was initialized, init function was called. Now the broker init function is called. Okay, so basically it depends upon how you import the package. So that's the kind of a very important thing to remember. Okay, that can cause some issues if you're not careful with this, because the way that you wrote the code, it really makes a difference, because depending the dependencies between the packages will make a difference. Okay, any questions so far?
No, I think I got it.
You got it. Okay. Okay, order of initialization. So basically every Go source file could have its own init function that we already kind of went over, right? Every file that you write, you can put in not only one function, init function, you can put in as many init functions as you want. So if there are any global variables in a source file, they will be initialized first. Okay, so now that is another key part to remember, that if you have global declaration, global variable declaration, they will be initialized first, and then the init functions will be called. Okay, so the init functions are called after global variable initialization. Order is irrelevant. Doesn't matter which order that you put it in your file. Okay, order doesn't make any difference. So in this example, basically I have init function right here, okay, and then I have init function, another init function right here. So there are multiple init functions, okay, and then I make a global variable right here. So this will be the one which will be initialized. Sorry, the line number 4 is not an init function; it's just a regular function, okay, and I'm uh, creating the global variable, and at the same time I'm initializing the global variable with this function, it will return some value. Okay, so when I run this code right here, which is 7, so you see it did the call me first. Okay, call me first, that is the one which was called because of the global variable. Okay, and the global variable was created after the body of the init function. So even if I would have this 13 line would be before the init function, still the global variable will be the one which will be initialized first. Okay, and then as you can see it in the output, that this init function is called afterward, and then of course the main function is printing the this print line statement at line number 16. Okay, all right. Multiple init functions in the same file. So you can have, as we just discussed, that you can have as many init functions in the same source file. So multiple init functions are allowed within the same source file. Multiple functions break up the complex initialization process. So now basically remember that we talked about earlier that init functions are good for initializing the database connections, and then opening up some configuration file. So you would not really want to put all that in a one single body of the init function. It is better to put it into the different bodies of the init function. So if anything goes wrong, you easily can identify which init function is causing the problem. Okay, and the code will be much more easier to read as well. So the init function avoid having one monolithic code block in a single init function. Okay? So uh, they say that it's best to do one task, basically. Do one task in one init function, have another body of init function, do another task in that init function, and so forth. So the init function are called in their respective order of declaration within the source file. So depending upon how they are laid down in your source code, first one will be called first, second one will be the second one, and so forth. Okay, so that's how the init functions work. So in this example, I have a variable called init counter. Okay, and this init counter basically is the variable that is being used in both init functions to increment the counter. So the first one will be called first, and then the second one will, starting which it starts at line number 13 will be called, and then the main function. So if I run this code right here, with example 8, then as you can see, called first in order of declaration. Okay, called second in order of declaration. So then from line 14, and then show the calling order. Okay, show the calling order, which is in the main, and then init the counter. Okay, so the init functions are kind of a handy tool. Okay, to be able to use. So before I start this error, maybe I think it's a good idea to take a break right here. Okay, guys.
Sure.
Okay.
So we take a break. 20 minutes is okay.
Okay.
Fine with me.
Okay.
Gets you access to license.
Hello, guys.
Hi.
Hi. Okay. So in the next half, we start the error handling. Basically, you already have seen, in quite a few examples, how to catch the errors, right? In returning, so when you call some function and catch if the error is not equal to nil. So pretty soon after this example, you will see that you can customize the error handling yourself. So let's start with this example. Errors indicate an abnormal condition in the program. So that, if any error occurs, that means there's some issues with your code. And in fact, you should always do the error checking while you are writing the code. So, you don't get into surprises when you actually are giving your code even to your testers to test the code. So it's always a good idea to go over the code while you are writing it. So when trying to open a file that does not exist, it is an error condition. So basically, your the attempt to open the file would cause an error. It was not a successful attempt. Okay, so in Go language, errors are represented using a built-in error type. Okay, so basically, there's a built-in error type that the language provides. So error values can be stored in a variable or returned from functions. The basic idea is that once it is stored into a variable, whatever the error is or the function is returning, then you can display it, on the screen that, hey, this is the error that was the cause of something, something. Yeah. So let's see in this very simple example right here. So I have FMT package imported and OS package imported. So the purpose of the OS package importing is to be able to open the file. So the way that we are opening up the file is uh, basically pretending, or we are assuming, not pretending, we are assuming that the file already exists, okay, in your file system. And when you do the open call, and if the file is not there, then that is an error condition. And the return call for this open, which we are, when we are calling it with the package name os.open, and when it returns, it will return either the error, okay, first parameter, or the first return value, and then the second return value is the file handler. Okay, so the F at line number 8 will hold the file handler, and ERR will hold the error. And then we check if the error variable is not nil. So not nil means it will be returning some sort of a number, or something in the error. Okay, and if it is nil, that means no error occurred. Okay, so if it is not nil, that means there is something in this error, a variable. Then go inside. So this is a true condition at line number 9 when you're checking it. So it will go inside this if statement, and it will display this statement, print line statement. Otherwise, it will come to line number 13 and display the name of the file. So that's what we are asking in the print line at line number 13, f.name. So name is a function within the OS within the OS package. Okay, so and it has been exported because it's a capital character. So that's the simple example of finding out if there is an error in the file or not. Now, let's get more, concrete or more better example of understanding how you can write your own error or using error package that the Go language provides. So the open function of the OS package has the following signature. So this is the signature of the open function that we just went over. Okay, this is the return values right here, file handler, and then the error. Okay, so these two are the return values from this open function. Handling errors in Go language is to compare the return error to nil. So, if there is an error, then the variable error will be holding a nil value. Otherwise, it will have something in that variable that in the return value. Okay, if the return value is returning a nil, then that means there is no error occurred. The non-nil value indicates the presence of an error. Never ignore the errors. So if there is an error happening again and again, then you need to be able to fix that issue in your code. Otherwise your code is not going to function properly. So the Go language allows to create custom errors which can be used in function or packages. So to do that, you have to use a new function, which is in the error package. Okay. So of course, first you have to import the package error, like you see it right here in example 6-10 at line number 3. So this error package is imported. Now, once it is imported, then you can use that package name, like you see it in this example, line number 10. It is using or calling a new function from that error package. So new function is basically going to take a type of string, okay, and it is going to display all this that you see in this double quote string. Okay, so that's how it is going to return. Now, even though this is the function, the circle area function is a normal function that you write in Go language. In this case, this function is taking a one parameter of type float 64 and it is returning two values. One is a float 64 and other one is an error. So when in the return statement, we are returning a 0, okay, and error this whole string with the error by using a errors package and calling the new function, and then you can pass any string that you want within this new function as a parameter. Okay, and then if everything goes normal, it is just going to return the uh, the radius of the circle, and it will return nil if there is, since it made it through line number 12, then that means there was no error. Now when I'm making a call from within the main function, I'm creating a variable called radius, and I'm initializing the radius with a -20 float type, floating number, okay, -20. So basically, that's that's the number that is being tested within the function, because that's the number. The radius is the one which is passed as a parameter to a circle area, right here at line number 17. So when I'm calling the circle area function, it is going to return two values. One will be the error and the other one will be the actual area that is calculated. So in this case, since radius is passed as a negative number, so within the body of this area circle area function, we do the checking first. Radius less than 0, yes, because the parameter is a minus 20. So then it is going to come inside this, create a new error message, and then return it, and it will be checked right here. So in this case, at line number 18, error not equals to nil. So it is not going to be nil because this message will be passed or initialized to ERR, and then it will be printed once you run the program, and it will print this same message, that area calculation failed. Radius is less than 0. Is right here at line number 10. Okay, so that's how you can create or customize your own errors messages. Okay. Go language, as you know, it has a FMT package, right? So FMT package also provides a function called error f. Okay, like FMT package provides a print line function, print f function. So it also has a error f function, okay, which does the formats or it does the formatting according to the format specifier that you use within this function, okay. And returns a string as a value that satisfies the error. So let's see how it is used in this small piece of code. So I have a circle area function again, same thing again. I pass minus 20 to the circle area function. So that's why it is this condition at line number 8 is going to be true. So it is going to come within the body of this if statement, and then instead of using package error.new as we used it in the previous example, we are just calling the error f function from the FMT package. So that's what FMT.error f. So, and then, this function takes the string, okay, and it has a format specifier. So basically this error f string works just like a print f, and it has a format specifier in there. So you can, use the format specifier to make sure that you are giving the data why it is failing, okay? So that's about it for this example. Any questions so far?
No, I think I understand that.
Okay. So there are different ways to write the error code, to catch it. And by using error f or by using new, so if you're just doing this simple thing, what I would do is unnecessarily I would not include the error package if it's a similar kind of a condition, because FMT package is much more commonly that we use it in our code, as you have noticed so far, right? So it's better not to include this error package just because you want to show that, hey, I know how to use this new function from this error. It's better just to use this function, because that way you are not adding extra code in your executable. Because remember, every time you import a package, extra code will be added to your executable files. Okay.
I don't understand why that makes a difference on like a workstation or a desktop or a server. I can understand why that makes a difference on a mobile, like a cell phone, or maybe not even really a tablet, because they have lots and lots and lots of memory and fast CPUs. That it doesn't really matter. I mean,
no, there is a good answer. Let me give you the answer on that. So, like like you notice that memory wise, bigger systems, desktops and anything like a workstation or like your laptop even is different than your mobile devices, which has
Yes.
which might have a less memory. But the point is that when you use or add extra packages unnecessarily, your code base, your executable will have to do, I'm going to be talking in terms of Linux, okay?
Hmm.
So, because I
Hmm.
don't know how Windows works on that regard. So, as you know, Linux is a page-based operating system. It
Hmm.
swaps in and out the pages, okay? Now, when it
Hmm.
is swapping in and out the pages, basically what is happening, the one major thing is happening is it is utilizing the CPU quite a bit, you know. Okay, you might even say that, okay, so what if it's a bigger system, if it is utilizing the CPU, what a big deal. It could become a big deal depending upon how complex your application is written. Okay, the performance, you will get a performance hit. I guarantee you, if you just unnecessarily start adding the packages, and not being careful in terms of, hey, I don't want to add extra code to my code base, So you
Well,
definitely.
I know it's good programming practice not to use things unnecessarily, but
Mhm.
it's just that I don't really see what, I mean, as a programmer, I stopped worrying about that stuff about 20 years ago. People told me that
No,
it was not worth my time.
no, it's not really true. It definitely worth your time. Believe me, Billy. It is. Um, uh, I mean, it again, as I said, depending upon how complex systems that you are creating. So, that if your system is very very complex, so it will have a bigger footprint in your memory, okay?
Hmm.
And doesn't matter even if you have 100 GB of memory, okay? And if your that device is doing so many things, your memory is very very important, okay? For example, let's say DNS server, okay? Let's say you want to write a DNS server. Now DNS server works on the based on memory, exclusively on the memory, okay? Everything has to be in the memory. Now in the your um, real DNS servers that these companies they sell, they are in thousands of dollars. They because they use a very powerful hardware, and they have a plenty of memory in there. So it raises the cost. But then the DNS software itself is so complex that it needs all that. Okay, and on top of it, if you are doing something like in like writing a DNS server in Go language, and not being careful about unnecessarily adding the packages, then there will be an extra swapping going on in terms of a coding, your code base. Remember that, especially if somebody is using a Linux, and I guess on other operating system is the same kind of a concept, but 4K page is in the memory, it will have to be swapped in and out again and again. And recently used pages are always going to be in the memory, and these recently used pages will be swapped back to the hard drive. So there's a lot of activity going on, in between the hard drive and in the memory basically. So, but it's up to definitely a person, and it really depends upon how complex the software is itself. If you're writing a simple software, then you don't need to really worry about it. You know, I in my view, once you start writing the code, you try to write it in a way that the code is written, especially if you're writing in Go language, and let's say you wrote a really nice piece of software, okay, but you were not very careful about the, using unnecessary packages and everything, and then all of a sudden you realize that, hey, this piece of code I can recompile without any change for a ARM based device. ARM is a microcontroller, right? ARM based device.
Mm-hmm.
Now you're going, and since you wrote a code, you spent like 6 months writing that code, and you know that this code, piece of code, will be very beneficial for mobile devices as well. Your intention initially was not that, but once you start showing it to people, they said, hey, why don't you, mobile devices are more popular these days, right? So simple thing in Go is very simple. We will cover that later. It's very, very simple to recompile your existing Go code for other architecture like ARM or PowerPC or anything else. Okay, so
Okay.
that's why I'm saying that it's better to be very conservative and use or write a code in a way that it is portable basically to any other architecture easily.
Okay.
All right. Uh,
Thank you.
yeah. So I think we covered this guy. Um, Panic and recover. Panic and recover meaning errors are sufficient for most of the abnormal conditions arising in the program. So you know, eh, you don't have to go too much into, uh, trying to find ways to catch the errors. The way that the language provides most of the functions that you use from the standard libraries, they will have some way to return an error, So that is sufficient enough for your programming, okay? But when a program cannot continue after an abnormal situation, use panic to terminate. So sometimes, you might come across with some code that, you want to be able to have a way that you want to continue the program instead of just terminating, okay? So if a function encounters a panic, the control returns to its caller and prints the panic message. So that's what it happens when the panic occurs. Okay. So but you have to use a panic call within it, then it will happen like that. So it is possible to regain control of a panicking program using a recover. So if something is in the panic mode, you can come out of it, you know. So it is similar to, I don't know if you guys have used in C++ try catch block,
Mhm.
it's similar to that. So the panic and recover can be considered similar to try catch in other languages, or even in Java that also has a try catch as well. So, those are the conditions that, if you want to recover from something bad happened, then, and continue your code without crashing the code. Okay. So
But
avoid
this
using.
isn't going to help. This
Mhm.
isn't going to help if you have something like a corrupted memory in this machine. The kernel generates a panic, though, right?
No, no, no.
Okay.
That's at the kernel level, right? Yeah,
Yeah.
that cannot be catched. This is only good for your own code, on your own Go
Okay.
language code. Yeah.
Okay.
So avoid using panic and recover, and use errors wherever possible. So don't unnecessarily, use the panic and recover. Try to use errors whenever possible. Okay. Even errors that we just went over, the catching in the last examples. So the use panic and recover where the program just cannot continue execution. Okay, so in that case you will use that. So in this example, what we will do is we will see how the panic occurs. Okay, so I have a function called uh, cake slice. Okay, and in that function I'm creating a slice of integers, okay, and assigning it to the variable called cake portion, okay. So that's a slice basically. And then I am using index or element number 3 from within a cake portion. So what happens? This goes from 0, 1, 2, right? And we are going to 3. So that is an invalid slice basically. So this is where this the panic will occur. Okay, so slice will generate a panic, and your program will be stopped. Nothing, you can't do much from it basically. Okay? So when you call this slice function, it will crash. Okay, so we can try to run it right here, and so where is it? Go run, and then 6 cells, 1, 2. Okay, so as you can see, when I'm running this code, it is saying panic, runtime error, okay, index out of range. So this is the index that we were talking about at line number 10. Okay, and then we're going to talk about Go routines. I think next class meeting or the meeting after, Go routines, what they are, and so forth. So, but looks like this this code, which is a slice code, is using the Go routines within itself. Okay, so but let's not worry about the Go routines right now. So basically, it crashed, as you can see, the program crashed. Okay, now in the next example, similar to this, in there we use a recover, okay, and it should be able to recover from it. So it is possible to recover from a runtime panic, as you saw it in this example that I just was going over. It just crashed my program. Okay, call recover in the above code when panic occurs. So everything is really same. Uh, I create the cake slice is exactly the same way as we saw it in the previous example, and in here we have that line in only new line in the cake slice is added is a defer retrieve slice. Okay, that is another function that I have at line number 6, which in this function I'm using a recover. So recover will be called, it will assign some value to regain, okay, and then if regain is not equals to nil, then recover. Okay, so if it is equals to nil, then it was not able to recover basically. And then once I call the cake slice from the main, I will go through it, and then it will generate this output, recovered runtime error, index out of range. Okay, so it did recover it, this index out of range, and it normally was able to come up to this point. Otherwise, it crashed. So because of the recover, okay, it was able to go back to the caller, meaning main. So function return back to the caller right here. Okay. So if I run this code, which is number 13, so recovered runtime error index out of range. So it is, printing out, where is this message? Right here. Okay. So this guy regain is generating a message index out of range. Okay, now in C++, there is the hierarchy. What is it called? The std package that will generate, when you, like, for example, when you use a new operator, and it generates exceptions, right? uh, it's a similar thing right here. You guys used it? You ever use the C++ um, what is the standard? What is it called? The classes. Uh, I can't remember the name right now, but similar kind of a concept that C++ provides. So, for example, C++ is a new operator. It will also generate this index out of range. And then you can catch the exception and then move on. Still go and finish up the rest of the piece of code, and that's what it is happening right here as well. Okay. Any questions right here? How to recover?
No, thank you.
Mhm. Okay, the start trace about the panic is lost after the recover. So basically, every time that you run a code, there is a stack is created. Right, when you run the code, but when you have a recover in there, okay, when it recovers it, it will lose the stack trace. Okay, so use print stack function of a debug package to print the stack trace. So right here, I'm importing this package called debug, which is under the runtime package. So this is a sub package. Debug is a sub package of runtime package. Okay, that is imported. Now, as this retrieve slice that we saw in the previous example is exactly the same way, except at line number 10, which is debug dot print stack, that being added. So what it is going to do, it is not going to, once the this uh, out of range error occurs, it is not going to be able to display the stack. Okay, so basically, when I have this cake slice, which is the same function as in the previous example, and at line number 15, again we are doing the defer. So you guys already remember the defer call, right? The call of defer will when will this function call occurs?
When the function exits.
When the function exits, right? Okay. So that call will occur once it is done with the body of this function, and then in the main function, I'm just calling the cake slice. Okay, and basically this output that you see right here, we saw it in the previous example, and then because of the debug, it is displaying the stack right here. Okay. So now I want to bring up this example and not this make sure that the error doesn't occur. So let's see what happens. Okay, so I'll just see. So I want to make this guy 2. Okay, so now there shouldn't be any error, right? Because there should not be out of range issues. Okay, so normally return from the cake slice, and then normally return from main. So everything went normal. So that means it did not go in here, debug print stack. So that didn't go in here because the error didn't occur, right? What I wanted to do was to see if it does the, so what I'm going to do is put it right here as well, and then see what happens. Okay. So now the reason I wanted to do that is to see what is the difference between this stack and this stack. Go routine, and then so this is the address of the stack. So now I get that something is on the stack, and then source stack. I thought it would give. Oh yeah, it does give me the names. Name, cake slice. Okay. To retrieve. So yeah, so it does actually give me um, the whole debug stack, uh, stack trace. So this is a stack trace, meaning every function that goes onto the stack is unwinded, like you can see it right here. Okay. I just wanted to see if it happens or not. Okay. Anyway, so any questions right here?
No,
No, I think I can do that.
Okay. Okay, so now next topic comes reflection. So reflection is the ability of a program to inspect its variable and values at runtime and find their type. Okay, so basically it gives you a way to see, the different data types that that variable holds, and on top of it, its value as well. So you get both two things from by including this package called reflection. Okay, so data type for the variables and the values of the variables as well. In Go language, reflection allows inspection of the struct type, interface type, fields, and methods at runtime. Okay, so that's a very powerful package that will allow you to inspect each of these things, so you can make sure that what your expectations that is right or not, in terms of are they holding the correct data, or they're holding the correct data type, so this reflection makes things easier to debug your code basically. Program does not need to know the names of the interfaces, fields, and the methods at compile time. Okay, so basically you don't even need to know the names, of, so remember when we pass the interface type, you know, for example, you don't even need to know the names of the variable, and reflection will help you find the exact names, or even if you have a custom struct, for example, it will give you in return, it will give you the name of an instance, so that's what the reflections does. So in the following program, type of num is known at compile time. No magic about it, right? So this is a very simple example to compare that. Hey, this is not a big deal to find the type. All you have to do is to %t, and it will tell you the type. Okay, that we saw it like 3-4 weeks ago already. So not a big deal. There is no reflection used. So that's a simple case. Okay, but there are very complicated cases where you might have to use a reflection package. So the structs that give access to the metadata of a running program are in the reflect package. Okay, so it's in the reflection package. So at the runtime, you can tell what this variable or this um, uh, uh, variable of type is and what the value of this variable is, okay, at runtime. So reflection is supported by following packages. So now, of course, it is supported by the reflect package itself, and then reflect package has type as well. So it's supported by the type and reflect value. Okay, so it is supported by that, and it is also has a kind. What kind of object it is? So it will tell you basically. If you are given the instance, then it will tell you, okay, is it an instance of employee, or is an instance of a fruit, or anything else? So it will give you the name, of actual data type. Name field, so that is also you can do it in C++ by including one of the header files. I can't remember, but that kind of a thing that you're allowed to do it in C++ as well. So num field and the field methods. So basically, that also can be done with the reflect package. Int and string methods. So all these are available in the reflect package. So reflection package implements runtime reflection that allows a program to manipulate objects with arbitrary types. Okay, so you literally can, manage to manipulate different objects during the runtime. Okay, the typical use is to take a value with static type interface, okay, and extract its dynamic type information by calling type of. Okay, so dynamic type will be what? Dynamic type means that it could be an integer, it could be a float, it could be a user-defined data type, or anything else, okay, or slice, so that would be a dynamic type which returns a type. So that's what you have to use, type of. Okay, so that is a function within the reflect package. So if I have this code, I first have to import the reflect package. Okay, once I imported the reflect package, then in the main I am creating a variable of type float 64. Okay, and then basically at line number 10, I'm using a reflect dot type of x. That x is a float type. Of course, we know it in this case. And then the value of x. So it will give me the value of x, whatever the value of x is going to be. So in this case, I get the value, but I'm converting that value to a string. Okay, so that will be converted to a string. So when I run this program, I will get a float type, okay, because the type of, that is the float type 64, okay, and the value, that means the data that x is holding, okay. So that value is going to give me the type, what type of value it is, basically. Okay, so that's what it is typing right here. Okay, the signature of type of includes an empty interface. Okay, so since this is type of is a function within this reflect package, it has a signature, which is right here. Okay, that's the signature, and it is returning the type. So it was just returning some type that, you know, type of data, basically, what type of data it is going to be. Okay. A call to type of returns a value representing the runtime data, you know. So basically, whatever is at runtime, it is going to be returning that value. Okay. So you understand what's the reflection, the purpose of the reflection is, right? To
Yeah.
find the type and the value of that type. Okay. So now, uh, basically, reflect.Type and reflect.Value. Okay. So in the previous case, we were using a type of function from the reflect uh, um, um, package. Now we're going to use type and the value function from the reflect package. So reflect package implements runtime reflection in Go. Okay, the two functions reflect type of and reflect value of, which returns the reflect type and reflect value respectively. So let's see how that is used right here. So in this case right here, what we have is at line number 8, first of all, we import the reflect package, okay? And then at line number 8, we have struct foo. And struct foo basically has field called first name, last name, and age. And so first name, last name are both string type, age is integer type, and then we are initializing that with the data. Okay, so we put it into this. This is called tilde. Okay, so it's surrounded with the tilde. Tilde key is right before above the tab key. Okay, and then we attach this function reflect. This is our own function reflect. We are attaching this function to the struct foo. Okay, so within the body of a reflect function, we are using a value of function from package reflect. Go ahead.
I don't see a tilde anywhere.
Right above the tab key.
No, on the presentation here on the page, I
Oh,
don't
no,
see a
not
tilde
sorry,
there.
not tick. I said tilde. It's a tick. It's called the tick.
Okay.
It's above, right above the tab key.
Yeah.
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 Good catch. Good catch. Yeah. I don't know why I said tilde, but it's a tick.
Tilde is shift tick.
Right. Exactly. Right. Shift tick is a tilde. Right. So this function reflect is attached to the foo struct. Okay, and within the body of this reflect function, we're calling the this function which is in the reflect package. Okay, so value of f, whatever the receiver is, f type, and then we are basically using ELM, element number. Okay, that's the element. So when I go through this field, so this is value dot number of fields. So it is going to go through each field in the struct. You see that how powerful it is. So it is walking in the struct that we have right here. Okay, and field value, and then that all that is field value, type field, and tag, they all are printed at line number 22. Okay, and that's what you see right here in the output. So first name, last name, age, and then field value. So field value is this. So it is all coming from this printf function at line number 22. Okay, and it is all happening because of it is able to read the elements. In this case, they call it element, but it is actually reading each field in the struct. Okay, that's what it is doing right here. Okay, so that's about it really. So these are the functions that reflect package provides to identify what this object is, what are the values of those objects, so you can easily get it by running it. Okay, any questions in here? Okay. Analyzing any function with reflection. So now in this case, basically we are going to see the functions itself, how to identify the functions with the reflection. So Go does not have an intuitive way of retrieving function names, but methods can be retrieved by their names. Okay, so you can retrieve the method. So in this case, what we have, again, we are importing the reflect package in here, and then we also have a strconv package, which is string console. That's what it stands for. And then we have a test struct, okay, and then I'm attaching say hello method to the test struct, and then I have a function analyze at line number 15, which is taking the parameter of interface type. Okay, now once I have the interface type parameter, that means this M could be of any type. Okay, and then basically here at line number 17, I'm using a package name reflect.Type of M. So it is X will hold the actual type of N, So in this case, whatever the type was passed to this interface. And at line number 19, I have num in. So num in is initialized with the x dot num in. So x dot num in is the count inbound parameters. So it is inbound parameters and outbound parameters. So basically, it will count the number of parameters. Okay, and in here I have at line number 22, I have a x dot string. Okay, so we'll have to run this program and see what exactly is happening. So in this case, I have at line number 22, x dot string that will print out the whatever is in the x is holding, and this is also going to check if that function, so x holds some function, so it's going to check if x is is holding x, is it a variadic function? Remember the variadic functions that can take any number of parameters with a with a dot dot 3 dots in it, as a parameter. So it checks, is it a variadic function? So it will return true or false right here, and then it will say package path. So that's another function that this reflect has. So it will return the path of wherever the package is. And in line number 26, basically, I'm counting the number of parameters in, going in and out. So counting the number of parameters, and it will go and it will check the kind. Okay, what kind it is. So the parameter it is, and it will display it right here. Similarly, it will check the out parameters. Okay, and then go into this for loop and display those parameters. So here, basically, I have a main function, and in the main function, I have this struct up above right here that we declared a test, okay, initializing the address of that test to a pointer type, you know, uh, basically the n is the one which is going to be holding the address, okay, and then method value, so it will have a method value. It means the n dot hello, so say hello is right here, you know, that's the method that we initialize with. And then function analysis, we pass this parameter method value to function analysis, which is right here. So that means we are passing what? We are actually passing this, the say hello function to this interface type parameter, okay? And when we run it, we will have the method name, which will be the function and the parameter. So it will display the whole thing, you know, in there. And it is not a variadic function, because this is, you know, this method that we have, it is not a variadic method. So that's why it is false. And the package that we are looking for, it is not in any package, so it's empty. It's a parameter, it doesn't have any parameter. So right here, when we go in say hello, it's taking the parameter, but where is it? One parameter z, parameter in, parameter out, parameter in. This code is not, so right here, yeah, let me go over this code in next class meeting, okay? This, guys, this looks like it's not that, there are too many things are happening here, okay? So let's go over this example again in the next class meeting. I don't want to
Okay,
say
that's fine with
something
me.
wrong, so we'll cover this again. I mean, there are things where which are some of the things are very obvious, but there are some of the things which are coming from this package reflect. They are not really that obvious, so I need to be able to uh, explain it to you a little better, so I can do that in the next class meeting, okay? So we skip that. And I'm really concerned with this parameter in, why it is saying 0 and this is 1. So where the heck this is coming from? That I'm
That's its number.
Huh?
That's its index.
Oh, that's an index?
Yeah.
Where do you see that index? Oh, you mean for this one? Index. Oh, in value. In value. So are you saying that this, where is the printf? I. So it's printing it right from here?
Yeah. That's what it says.
Yeah, it is. Yeah, it is. Yeah, right here. It's printing in. So it's just printing this I. That's all. But what about this? What about this guy, INV? INV. I don't see the INV. INV is a
You do
kind.
it down on line 31.
Yeah, yeah, this kind of function right here. INV, so line 28, right here. So in underscore kind, in underscore
And then
kind,
you
line
print it right
31.
there on line
Yeah.
31.
So, and then the name. So it is printing 0 and the kind is string, and then the name is string.
That's wrong.
Yeah, that doesn't sound right. Yeah, why is that string? Okay, we'll explore this example next class meeting. I don't think it's a good idea to spend time with that right now. You know, plus the way it is written, you know, the lines going to the next continuation of the line, it makes it harder to read the code. Okay, that's fine. We'll cover it next week. Okay, handling pointers with reflection. So if the pointer value interface value is a pointer, use function reflection indirect. Okay, so basically, reflection package provides the function called name indirect to convert a pointer. Somebody's
Not me.
it's not you. Maybe Dash. Are we listening the songs?
No, no, actually, I don't know. My computer suddenly started with them.
Oh, all of a sudden, okay. All right. So, you know, in this case, basically how to handle the pointers using a reflection. So the way that you handle it is because reflection provides this function called indirect. Okay. So we have to import the reflect package, and then we have a person struct, and basically, in this case, this struct has one field called name, you know, in there, and then we attach a function called print foo to this person struct, and it, it has a receiver. So receiver is used within the print um, line function, and then in the main. So this is pretty straightforward. Within the main, I create an instance of the um, of the person struct. Okay, so that's up till now. It's not a big deal, and then return the reflection value of a pointer, the address. So basically, reflect dot indirect. Okay, and then within that we use a reflect dot value of emp. So we are looking for the value of emp. Okay, so it is going to tell us that this um, right here, um, we have output we have output value dot type dot field dot name. So basically, all this thing is getting to this struct field, right? It's all this is getting us to the struct field without without uh, 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 you know, knowing the name of the struct itself. Okay, so that's what, as long as you have created the instance, then you can access the actual name, you know. And all the time so far, what we have seen is getting the data which is stored on those fields. Right now, what at line number 22, what we are getting is actual name of the field. Okay, and this, you know, field 0, that means in this case it is only one field in there. If that would be a if there will be a multiple fields in this struct, then you will have a, you know, 1 and 2 and 3 and 4, you know, all that in there. So this is how you can get the field names from the struct by using, this reflect indirect. Okay. And then the value. So if you want to get the value, you just have the value, meaning the data. So the data is stored right here, line number 16. So this will give you the data. If you just do the value directly, then you get the data. And then this is the simple way that we have used it all the time at line number 24. It is just going to give you the tell you that this is located at some address location, and it is just showing you that the contents of um, the instance um, of the struct. Okay, that's about it. Oh, I have one more. So, any questions so far? This example seems pretty straightforward, unless you have any question.
I'm gonna play with it. I'm gonna figure it out some. It's okay, thanks.
Yeah. So indirect is basically a purpose is that you can access the field names from the struct. That's about it. Okay. That's the indirect allows you to do. So for whatever the reason within your code that you want. Now, these kind of things, you really want to use it if you're writing some utility program or some sort of interpreters, then you would want to be able to use these things from Go. Otherwise, in the regular programming, this hardly you would want to use it really. Okay, access private fields with reflect, with reflection. So with reflection, it's possible to read but not write unexported fields of a struct defined in another package. So basically, you can read the unexported field if you want to, okay, by using a reflect package. So access the unexported field length in the list struct in package container. So, as you know, that Go language provides the list. So uh, this is how it looks like, the container for list in the Go language. Okay, source code. So following code reads the value of length with reflection. So in this case, I import the list container, and then I also have a reflect package, and then this is how you can use the list. You're creating a new list. So once you create a new list, instance of new list, L, you can use L dot push front. You're pushing some data into that node. Okay, so you created a one node, and then you create another node, and then so these are all so you're pushing it. So that means this will be the first node, this is the second node, and this is a third node. Okay, and then at line number 17, you are using this reflect.Value of. Okay, value of what? Value of list dot element dot field name. So field name is this length, so in case of this container, the field name, as you know, that length is all small characters. Okay, but you can access it by using this reflect package, and that's what it is doing. So it will have this it will be saved into fv field value, and then you can use the field value dot int to display how many nodes are in the list. So there are 3 nodes, right, as you can see right now. Okay, and if you try to set the value of length, if you try to basically use a set function, you would get an error. This is not permitted. You can only read, but you cannot modify it. Okay. So reflect package is pretty powerful, and there are some things that are useful, but it's not really, um, for the regular development. You would not really want to use the reflect that often. Okay. So any questions so far? Let
I
me
think I got it.
Okay, so let me go over the assignment really quickly, so that way you guys can start. Uh, so this assignment is due not next week, but the week after. Okay, and the reason that I have given you 2 weeks is because it's kind of complicated. Uh, just make sure that you do a good job in it. Take your time. That's why I'm giving you more time. So so that you're good thinking in it. So these are all the same things, and it also says do not use container package for linked list. So that means you have to create your own linked list. This is a regular linked list. This is not a, you don't not treat this as a stack like the last assignment. Okay. Um, so make sure that you go through these. And now you need to use this iota for the purpose of this menu. Okay, so when you use iota, in iota you will have a add, delete, search, list, and so forth. And then you will have a switch statement, and then you call the add function, delete function, and so forth, like you have kind of done it in the last assignment. You need to have a command line argument. So we covered the command line argument in the last class meeting.
Mm-hmm.
Okay, so you pass the file name. So the file that we were talking about earlier, this is the file. Okay, I will upload that file hopefully tonight, so you will have access to it. And basically, what else to say? Oh yeah, this is kind of important right here. Adding an employee in a sorted order while reading a file. So you guys understand what that means?
Sort the file and then add the employee where it would go in the list.
No, 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 no. So this is the file, right? So
Yeah, and
while
sort it into a linked list.
right, so
Make a
while you
linked list, sort the list, and then put an employee in the list where it would go if it was in alphabetical order.
right, but you do not put this data in the linked list, all data, and then sort the linked list. No, you don't do that.
Sort
You
it
read the
first.
yeah you read the data from the file, create a node, and then you read another line, another record, and check that where is this node is going to go to in the list. Okay, so while you are creating the list, you are sorting it.
Okay.
So that's kind of sometimes some students get kind of confused because maybe I worded it this way or what. So it's saying adding an employee in a sorted order while reading a file. Okay, so you read one line and then create a node, and then read another line and create a node, and then decide where that node is going to go, alphabetize it. Okay, so that's basically it for that. And this is so this is the menu you will show. Okay, and this is the file that we went over. Where is the output? Output is right here, and this will be the output. Okay, so when I do the this selected list all employees, then I should see this output. And the other thing in this table right here is that of course, you need to save linked list data into a file. So when you are saving so you don't have a multiple files, you just have a one file. When you are saving the data back to the file, you will save it in the same format, okay? Just with the delimiter semicolon. You save it in, so if I want to add more records, I'll just add more underneath, okay? So when you're saving it, your file, that means your file will be automatically be sorted because your linked list, you're keeping it sorted all the time. And when you dump your linked list to the file, it is already been sorted. Okay, any confusion or?
I think I got it.
Okay, and then other thing that is very important, and I think I'd say it right here, usage of comma in a salary field. So this is what I'm talking about. Okay, so you basically, in this case, there is no comma necessary, but if it goes to 1000, then it is a 1 comma, and then 00, and so make sure you put a comma in the salary. If somebody has 100,000 or 200,000 a year nowadays, 200,000 is very common. So put a comma at the proper place. Okay. So any other question that you think about this example, this assignment?
No, I'm fine.
You fine? Okay. Okay. So, Dash, make sure that you take care of your interviews, of course, first. But in the meantime, you also do the coding so you are not late. I know last time you did it pretty quickly, actually. I was, very impressed that the number 3, you did it really fast. Maybe you didn't have any interviews during that time.
Yeah.
Okay. All right, guys.
Okay.
Any other questions? Otherwise, we will see you next class meeting. And we are coming pretty close to going over, go routines and channels and all that stuff. So some very interesting topics are coming up pretty soon.
Okay, cool.
Thank
All
you.
right. You're welcome. Okay, see you next week.
Bye-bye.
Bye-bye. Okay. Bye.